Again, data science is a fully managed platform for teams of data scientists to build, train, deploy, and manage machine learning models using Python and open-source tools. It's available in the machine learning stack under Analytics and AI. You can select data science from this machine learning stack under Analytics and AI. Once you click on this data science, it will bring you to this particular page. You can click here and see some of the basic prerequisites needed. And you can already see that I have an already created project in active state. You can click on Create Project, select your compartment, give project name and description, and then click on this Create button, and this should create a project for you. After clicking on this active project here, this is how the page will look. You can see multiple notebook sessions which you would have created, their state, compute shape, network, and endpoint details. In the left pane, apart from notebook sessions, you have an option to view and create jobs. This is how it looks. Pipelines models. You can see multiple models which I had created earlier. And again, model deployments. Let's go back to notebook session. Now to create a notebook session, click on Create Notebook Session. You can then select compartment, provide the name of this notebook session. If not, the system will automatically create one for you. Again, you can select compute shape as per your need, and of which there are a lot of options. So if you click on Change Shape, you can see you have a lot of options with respect to instance type shape series, where you want to use AMD, Intel, or some other shape. And then you can also define the number of CPUs and amount of internal memory. And then click on Select Shape, and that will select a compute shape for you. You can then define your block storage, networking resources, and endpoint type. And finally, then click on Create button here. For this demo, I will click on this existing notebook session here, which now brings me to another page where you can see some additional information about the session itself along with different metrics. I will open this active session, and that will bring me to our Jupyter environment. Usually, to begin with this notebook environment, you click on this new launcher. That will open a launcher tab. This usually have environment kernels along with some other resources. The first step is usually creating a Conda environment, which is a prepackaged environment with multiple libraries as per your use case. So let's click on Environment Explorer, which will open another tab for you. Here, you can see multiple Conda environments. Let's expand any one of it. So here you can see some description about that particular Conda environment. What are the different libraries or packages in that environment, as well as the steps to install it. So let's copy this. And to install it, you go back to Launcher. You click on the terminal, which should open a terminal for you, and then you copy-paste the command and run it. So once you copy-paste and run it, it will install this Conda environment. And probably after refreshing this, you should see an additional kernel right here. Once you see your choice of kernel created here, click on the Conda environment kernel. For example, I will click on this, and then click on Create Notebook, which will create a Jupyter notebook for you. So I have already created a Jupyter notebook using this Conda environment. So my Conda environment is General ML, Machine Learning, with Python version 3.8, and this is the Conda environment. You can also select or change your Conda environment kernel right from here. The code in this notebook is very similar to what we saw earlier in the machine learning module, with some additional libraries such as ADS as needed, and some extra steps to showcase data science service. So we will start with importing required libraries. So let's complete this step. Then we will load the iris data set as we did earlier. So we have loaded the iris data set. Then again, we will split the data set into features and target variable. Split the data set further into training and testing sets. Let's see what each of the data frame shows. So this is the features, these are the features, and this is the target variable showing the first 5 rows of the data set. Now again, let's train the model, train the classifier. In this case, we are going to use random forest classifier. Once you have trained the model using the framework of your choice, which we just did, now, we will create a model object and call this prepare method, which generate all the required model artifacts needed to deploy a functioning model, without you having to configure it or write any code. ADS library, which we had imported earlier, help with all of that. So let's run this particular cell. Next, you can then call the summary status method, which will return a pandas data frame that guides you through the entire workflow. So let's run this cell. This will show which methods are available to call and which ones aren't. Plus, it also outlines what each method does, and then if extra actions are required, it also shows those actions. So you can see the output now. So all the steps: initiate, prepare, verify, save, deploy, and predict, and their respective status as well as any action needed, along with the details. So you can see we have initiated and we have prepared. Those two steps are completed. So the verify method now, it simulates a model deployment. That means you can debug your files or test the model without actually deploying a model. So let's run .verify. So you can see from the test data set, for the first 10 rows, it has done the prediction successfully. Then comes the save method. The save method deploys a model artifact to the model catalog. Let's run this cell. So now the model is successfully loaded. Now you can see the first 4 steps: initiate, prepare, verify, and save are completed. The deploy method, it deploys a model to a REST endpoint. And the predict method here, it generates prediction by invoking this deployed endpoint. So due to limited scope of this demo, we want to go further beyond saving a model. But again, I have written these steps for you in case if you want to complete these further steps on your own. One other thing I want to show you is this model itself. So let's go back to our notebook sessions. If you click on the models, you will see this newly created SK Learn model.